Okay, in this video we are talking about the conversion of the sensor value to the pressure value, and therefore I open up a new section, include a command, convert the data from 8-bit to 64 Newton per square centimeter. And now we can think about it, how to do that. And we are naming a new variable. I call it pressure in this case, so that I don't have to type that much. So the data in the file are bit. And so we have 8-bit. And 8-bit reaches from 0 to 255, and so we have to divide our measurement data, which is this one, the main without offset. We divide them with 256. And now, after that step, we multiply it with 64 for the 64 Newton per square centimeter, and we should have the right pressure. We run this section and look up how the pressure looks like. So in the beginning, as I told you, you have at some sensors, according to the offset, a negative value. But you can see these values are pretty small in some sensor case, but on some sensors you have a pretty high negative offset. Okay, and we can see there is the data in there. We also see the pressure is not that high in some regions. And you can look up that on your own, but that's the procedure how it works. And you can plot the measurement data again in this step. So we copy that one down. And plot our data. We take the pressure, put it in there, plot it again, so we run this section, and we should get and plot on this side, and we can maximize this window. So by open in figure window, we force a separate window, and we now get a window how we are used to it in the normal MATLAB section. And you see there are 2 or 3 sensors in there. They are on negative values due to the high offset on the insole. So during the preparation you should keep focus on that you don't have these large values down here. And what we can see is we get at some points in a saturation of single sensors. So this point show us we have during time period of in this measurement values, we have a saturated sensor. This means that we can't measure the peak in here, and so we haven't the whole information how high this step was. This is because I don't make the normal steps for this test measurement, so I've jumped and so on. So to keep that in mind, I will pick steps After that first one, it's about 4000. Okay, now I know how the data looks like, and I'm supposed to do it that way, and we see down below single sensor data, and we see these ones are underneath 0, so we have the 0 line here, and we see some sensors are on a value of -5 in this case. That's due to the offset measurement. Good, come back to the main script. We now have pretty much done from the workflow, so we have subtracted the offset, we've converted the measurement data, and the next point is to cut some data out, and therefore I make a new section break and we cut 6 dance faces out with the command ginput, and you get back from this function the x and y coordinates. The x and y coordinates. Input. And you have to say, you see it here, a number of points which you can grab. So I take 2 because I want to grab the start point and the end point, and then I run this section and I get a window which I want to maximize to a certain point, and then I see as well, okay, this one is saturated, so I don't take this one, and I take 6 dance faces after that. So I click here, I take this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this 11 looks good, and minimize the window, and then we see, okay, we get these values back. So the start point is on 4437 and the end point is 9555, and we take these values to cut the data down to only do the data preparation in the further steps with this cutted data. So we include in x1 this value, and x2 we see is the second value to cut, and then we can cut this whole data. We call the new one only data. And I take the pressure variable in this case, and from pressure we take it from x1 to x2 and all the content in there. So we run this section. Okay, he wants to do this G input a second time, so we comment that out when we've done, and we run the section, and I should see now the data variable. Minimize all these windows. Yes, we see now a smaller data variable. You see it in this case with 5000 rows, and the other one have 17,000 rows. So that works perfect. I've chosen this one only for an example because the data which we are collecting with ginput is already in this one. So we can change the code to get the value out of this x value. So the variable x1 is this one. So we can reduce to to a shorter code, x1, in this case x2, and this should work the same way. We save and run the section, and we get an warning because only integer operands are required, and this is because we should round the value down to 0 commas. We are doing that by looking up the round command, how it works. So it rounds down the value to the next integer. And now we are trying how to include that in our code. So to minimize the amount of lines of code, I try to include it in there so that it gets rounded down, and we rerun the code and we see the error message is gone, and we look in the data variable and it works the same way. Perfect.